Round two, let's go. All right, so the next one we got to start thinking about is consumer behavior. So now we've learned a lot about, okay, how does the quantity demanded respond to changes in prices? How does the quantity supplied change to prices? How does quantity demand change to income? How does quantity demand change to price changes in other industries? I know that's a lot. I know that's a lot. There's so many things to go over in this class. So that's why we do it together, right? We got this. Now we need to think about how do consumers think. So consumers, they get to choose between a bundle of goods, right? Like we just did a whole bunch of numbers for one good or a set of goods, which I think in the assignments and the quiz, I give some situations where you might plug in numbers into those equations, very simple numbers, nothing tough, right? And we talk a little bit about how those differences are. But then we have to think about how do consumers react when given a series of goods that they can choose in between and their responses in between different ones, right? So we have to think about consumer behavior. So we have a couple different things. We have opportunities and preferences, right? Opportunities are the sets of possible goods and services that you can afford to consume. I can consume lobster and I don't know, mashed potatoes or something. I can consume shrimp and grits. I can consume cauliflower steaks and carrots. But that doesn't mean I'm going to, right? I have the opportunity and lots of possibilities. I'm vegetarian, I would have only taken the third one, right? The other ones are just possibilities. But I have preferences among these. So because I'm a vegetarian, I'd probably prefer the cauliflower steak to shrimp or steak. I might have preferences in between the other two. I might have preferences in between, for example, what do I have? I always just kind of look at the desk to see what's around. Okay, we got blue scrunchies, black scrunchies, white scrunchies, because I am still, or gray scrunchies, I am still stuck in, I don't know, 1994, but I like scrunchies, they're kind of cool. I probably have preferences though, right? The black scrunchie, this matches with everything. The gray scrunchie, great for working out, can match with most things. Gray is a good neutral color. Blue, kind of cool, only matches with some of my outfits though. It might be clashing with others. So I have the opportunity to have any of these goods, right? But I'm gonna have preferences. Consumer preferences determine which one you end up consuming. I can use one of the three in my hair, right? But I might have a preference on which one. I might always prefer the black one to the gray or blue one. I might prefer the gray one to the blue one, but not necessarily the black one. These types of preferences are things that we have to learn to organize and we have to learn to measure when we're giving people a selection of goods that they can choose from. Because sometimes it's much more complicated than which hair thing do I have, right? Sometimes it's which car does someone buy? Which neighborhood do they live in? How do they travel? Where do they go? If they go to the grocery store, do they tend to buy 10 different products together or will they buy a purchase or bundle of one particular set of goods? We have to think about what consumer behavior is and how it determines the preferences among the different opportunities that they have in front of them, right? So we got 4 rules to the properties of consumer preferences. First, for any 2 bundles of goods, we have one of 2 situations, right? And we'll go back to our nice little scrunchies. We got our black scrunchie, we got our gray scrunchie. Okay, for any 2 bundles, you can prefer good A to good B. You see that little sideways caret? That has to do with having a preference to it. So in this first one, you say that, for example, I prefer the black scrunchie to the gray scrunchie. All right, the second one, it says B is preferred to A. Okay, so that might mean that I prefer the gray scrunchie to the black scrunchie. The next one you see is a little squiggle in between A and B. That means indifference. So I am indifferent in between the black and gray scrunchie. That's just 3 different ways that we have to kind of put it together. But for every 2 sets of goods, for every 2 bundles of things you can purchase, you're either going to prefer one, or you'll prefer the other one, or you'll be indifferent in between the 2. There's no other option. It has to be one of those. We call this completeness. It's one of the laws of economics when we're talking about preferences. All right. The second preference is the idea that more is better. This is a strong assumption in econ because we know, like, sometimes in reality, like, you really don't want 25 pizzas, but in economics, we're going to assume you do. We have this idea that more is better. You always prefer 5 pizzas to 4 pizzas, even if it's only a little bit of a preference more. You always prefer 25 pizzas to 20 pizzas, even if it's only a little bit of preference more. If bundle A has at least as much of every good as bundle B, and then more of some goods, bundle A is preferred. So if I what's a good, oh, I have a second black scrunchie. Okay. If I have two bundles of goods, they both have a black scrunchie. This is good A, this is good B. Okay. You would think that I'm indifferent, except let's say that this one has a black scrunchie and a gray scrunchie. Well, I'm just dropping stuff at this point. Okay, black scrunchie, gray scrunchie. Okay, well, notice bundle A right here with the black scrunchie and the gray scrunchie. It has as much black scrunchie as bundle B, as much, but it has the bonus of it has extra things. It has this extra gray scrunchie in it. I'm going to prefer this bundle because not only do I get the same thing I already got, but now I get more. It's the idea that mathematically in economics, when we're thinking about the average preferences of the average consumer, that they tend to like more things. 3, diminishing rates of substitution. Okay, this one's the idea is as consumers obtain more of one good, the amount of good the other one's willing to give up decreases. Let me show you in a graph what that means. Because this idea of diminishing rates of substitution, this one kind of matters. So it's the idea, oops, yeah, let's go right here. And we'll just go down a bit. All right. It's the idea that when I'm thinking about, for example, let's have Coca-Cola and pizza. Notice that in this one, I'm not necessarily looking at price and quantity. What I'm instead doing is comparing the markets for two goods. That's something we can totally do with the same types of graphs. And typically, it looks like how I have preferences in between them. So let's say that it looks something like this. We tend to have a bit of a curvature to how people prefer goods. And let's say we go, I don't know, 10, 20, 30, 40, 50 cans of Coca-Cola. All right. Then let's say we have pizzas along the bottom. And then let's do the same thing. Let's say we have 10 pizzas, 20 pizzas, 30 pizzas, 40 pizzas, and then 50 pizzas. Okay, let's see what this relationship is. When I have 0 pizzas and a ton of Coca-Cola way up here, well, I would really like some pizza. That would be great. Actually, let's start with 10. Maybe I have 10 pizzas, and when, oops, come on, stop freaking out on me. And when I have 10 pizzas, maybe I have, what, 27 Coca-Colas. Maybe I would really like more Coca-Cola. I'd be willing to kind of trade in between the two. So maybe to go to, or I'd like more pizza, maybe to go to 20 pizzas, I'd be willing to go from 27 Coca-Colas down to, I don't know, 17 Coca-Colas. I'd be willing to reduce by 10 so that I'm able to add 10 here. Okay, well, that totally makes sense. That totally makes sense. But what happens when there's more extreme examples, right? Let's say instead we have it as, maybe we're moving from, oh gosh, stop deleting my dots. No, all right. Maybe we're going from that 20 pizzas to 30 pizzas. Well, at this point, I'm kind of full. I have like 1 soda per pizza. Like I'm doing pretty good, right? So if you want me to continue to reduce from, let's say that 17 sodas to 15 sodas, well, you're going to have to compensate me a lot, right? Because there's diminishing return to pizza. Like for that first 10 pizzas, notice I was willing to give up lots of Coca-Cola. So I went from like here to here. For that second 10 pizzas, like I was willing to give up a decent amount. I was willing to give up a decent amount of Coca-Cola, right? For this 10 or next set of 10 pizzas, like I would like something to drink. I do not necessarily want, stop doing this. I do not necessarily want to lose more Coca-Cola. So to lose even a few Coca-Colas, like the 2 Coca-Colas that I'm losing, you'd have to compensate me a lot of pizzas. Like you'd have to give me 10 extra pizzas to be willing to lose 10 Coca-Colas when I am this close to being out, right? It's the idea that the more and more pizza that I have, the less and less Coca-Cola that I'd be willing to give up for it. The more and more Coca-Cola I give up, the more and more pizza you need to pay me to continue to give up Coca-Cola. It's the relationship in between the two. We typically like to be in the middle, right? We kind of like to be in the middle of this curve where we have some Coca-Cola, and some pizza. That's great. A lot of the time we don't like having only pizza, and a lot of the time we don't like having only Coca-Cola, because if we have only one good, then we are significantly better off if we have even one more of the other good, and we'd be willing to give up for it. So if it's two goods that we value, we prefer to have a little bit of each, and that there's diminishing returns to it, or diminishing not only returns to it, but the marginal rate of substitution, what I'd be willing to give up of the other good for it. So to give up, for example, 10 pizzas, my marginal rate of substitution to add 10 pizzas might be subtracting 7 Coca-Colas. So it's a relationship of -7 plus 10. For the next one, to go to 20 pizzas to 30 pizzas, to add 10 pizzas, I would lose 2 Coca-Colas. So -2 Coca-Colas for an increase of 10 pizzas. The marginal rate of substitution kind of changes depending on where you are within the graph. But that's if it's a curved graph. If we have a straight line, then that rate always stays the same. So I think what we're going to do is we're going to start off our examples thinking about the straight line, and then eventually come back to this where we start thinking about the bundles of goods that people are choosing in between. The bundles of goods people are choosing in between and their levels of preferences within them are called indifference curves. What sets of goods are people necessarily indifferent to? In this one, notice that we have one curve. I would call this an indifference curve, where 10 pizzas and 27 Coca-Colas is worth the same to me as 20 pizzas and 17 Coca-Colas. I'm indifferent in between those two bundles. That's called an indifference curve. We'll circle back around to that though. What we really need at this point in the notes is just the idea of this diminishing marginal rate of substitution. The more and more I have of something, less I'm really willing to give up to get more of it, right? For that first pizza, like it is late at night, you are tired, you have been working all day, you're ordering pizza, that first pizza, you're just like, this is great. I'd pay like $15 for that pizza. The second pizza, well, if we're thinking about how I'm willing to substitute in between the other stuff my money can buy in pizza, I'm like, oh, I could buy sodas, right? That first pizza, I'm willing to pay $15, but that $15 means I am giving up 15 potential sodas. All right, well, for that second pizza, maybe I'm only willing to pay $10 or only willing to give up 10 potential sodas. Maybe the next one, I'm only willing to pay $5. I'm only willing to pay 5 potential sodas because at that point I already have 2 pizzas. Why do I really need a third pizza? So the rate of substitution in between two different goods that I'm wanting to purchase, this changes over time. Don't worry. I know this sounds like a lot. We'll do examples. We're going to work through it. The last thing is the idea of transitivity. We need preferences to make sense, right? When we have 3 or more goods, we need to have some sort of relationship in between them. That's the idea of, I like the black scrunchie more than the gray scrunchie. I like the gray scrunchie more than the blue scrunchie. Therefore, I have to like the black scrunchie more than the blue scrunchie. There's no way around it, right? The same thing works for indifference. If I do not care if I have the black or gray scrunchie, I am indifferent between them. And I am indifferent between if I have the blue scrunchie or the gray scrunchie. I don't care which one I have. Then that means I have to be indifferent in between the black and blue scrunchies. Okay. All right. Wonderful. Wonderful. Transitivity just means that preferences make sense. We don't have people going crazy, right? We don't have people saying like, I like the black one more than the blue one, and I like the blue one more than the gray one, and I like the gray one more than the black one. That doesn't make sense, right? It doesn't add up for transitivity. So for our consumer preferences, we need to have a few things. We need to understand our preference in between any two goods. If we like one more than the other, or if we are indifferent. We think that more is better. We always like more of something, but we also have to think about what we're giving up of another thing, right? We think about the bundle of goods. 3, there's a diminishing marginal rate of substitution. The more you have of one good, the less you're willing to give up of the other good to get more of that first good. And then 4, transitivity, you have some alignment of preferences. If you like something the best, you like something the best, regardless of what other things you're thinking in between. All right. Woo, let's think about budget constraints. So budget constraints are a really great place to start when we're thinking about indifference curves, when we're thinking about budgets. Okay, let's talk about what that is. So let's start drawing this one. Budget constraints is just the amount that you can purchase of two goods. So we're going to get rid of the world where there's a whole bunch of goods for you to choose in between, right? Because that would just be so many graphs that it's ridiculous. We need to think about a world that only has two goods. So I'm probably going to stay on the Coca-Cola versus pizza for this, just because it's a little bit easier to do if we stay consistent with the same good. So budget constraints are restrictions set by the price and income that limits the bundles of goods that are affordable to consumers. So we have two different things. First, we have a budget set, and then we have a budget line. I have an example in the slides, but first let's go ahead and draw it out so you can see each part of this. So let's, while we're at it, let's just move this over and let's have, no, that's fine, you can stay there. Let's think about if we were wanting to write a budget constraint. Well, let's first do a budget line. A budget line lets us know what the absolute maximum we can afford is. So let's say that we have two goods. We have our Coca-Cola and we have our pizza. Well, first we need a total amount of money. We typically in our notation call this M. All right, so let's say M this time we have, I don't know, let's say $500. Okay, all right, wonderful. Well, if we have $500, there's a couple other things that we need. We need PX, PY. All right, so PY, Y is just whatever is on this up and down curve. So in this one, this is going to be essentially the price of Coca-Cola. This is Coca-Cola. And let's have this equal to, I don't know, let's say $2. Let's keep our numbers nice and easy because it makes it a little bit easier for us. Then let's go into the price of X. So the price of X, this is going to be whatever it is for pizza. So let's say that this is pizza because X, remember, is our horizontal axis. Pizza, let's say, is $10. We're just going to make life real easy. Okay, the budget constraint is the line of possibilities of the different things that you can purchase. So what are the parts of this? Well, first off, what if I only purchase pizza? Okay, if I only purchase pizza at $10 and I have a total of $500, the maximum amount of pizza that I can buy is what, 50 pizzas? Yeah, cool. So that's going to be equal to our X. X is just the total amount of quantity of pizzas that we can end up having, right? Or the total amount of pizzas that we end up having throughout the relationship. So this is X if we only consider pizza, but that can kind of change depending on the relationship. So notice that our budget set is the price of X. So the price times the number of X that we purchase plus the price of good Y times the number of Y that we purchase. If we only purchase X, then we would only have the $10, right? The $10 for the price of X times the 50 pizzas, and that would be equal to the $500. But let's consider that we might also want Coca-Cola, right? Because Coca-Cola, that's cool. Sure. So if Coca-Cola is $2, then the maximum amount of Coca-Cola that we could buy, if we only purchase Coca-Cola and we use all of our money, right? That's going to be what? 250 cans of soda. Random fact, I've never had a soda, but I hear it's good. Anyways, so if we only spend money on Coca-Cola, then we would have 250 Coca-Colas and nothing else. Now, notice you might be miserable in that world. You may not want a world where you only have pizza or you only have Coca-Cola. Generally, people like both. So with the line in between them, if we were to draw a straight line, and assume that that's straight because I just cannot draw, but it's close enough. That just represents, all the possibilities that we have. So for example, one thing that we could have is we could have 10 pizzas. So let's see, if we have 10 pizzas, that'd be $50. That'd leave us $450 remaining. And then what, 225 sodas? We could have that and be about right here where we have 10 pizzas and 225 sodas. We can also have a world where we have maybe 40 pizzas. So 40 pizzas times 10, that's 400. So we'd have 50 sodas. We could have 40 pizzas with, let's see, what, 50 sodas, I think? Yeah, that makes sense. All right, so we have this sort of connection where we have a relationship where we can talk about what we can afford. Now, this line, this is us maximizing our budget set. This budget line represents that we are using all of our money and we are being efficient, right? We are maximizing efficiency by purchasing to the maximum of our ability to purchase. That's what that budget line represents. Everything inside the budget line, we call this attainable. I can purchase any of these. I can technically, if I have $500, buy only one can of soda and one pizza. I can do that. It's just, would I, right? If I only had these two goods in this world with this amount of money. We can also think about points outside of this. Like maybe if I had 50 pizzas and 225 sodas. Well, that doesn't make sense because we don't have the amount of money to buy it. These we call unattainable. Any point outside the budget line, so way up here, these are ones that we cannot purchase with our current budget set. Ones inside the line, these are attainable. And we have to think about what the budget set and the budget line represents. So the budget line represents us maximizing our efficiency because we're using all of our money. Everything inside this line is part of our budget set, but not maximizing our amount of money being used. Then we're not using all of our money. Okay. So let's go back to the slides. Yeah. Nope. Okay, so if we go back to the slides, notice that we have this relationship here. We have two different parts that are m divided by py, and we have m divided by px. M represents that total amount of money. In our example, that was the $500 divided by the price of the good. $500 divided by the $2 for the soda meant that the total amount of soda that we could have was 250 sodas. That's what this point right here represents. M divided by PY, that's just the total amount that we can purchase of one good if we only spent money on that one good. It's where our intercept is for our y-intercept. Then down here we have M divided by PX. M divided by PX is the total amount of money that we have divided by the price of the good of X. In this one, we had pizza, right? So it's the $500 divided by the $10 pizzas. That's 50. That would be our intercept right here. So I think I use a different example. Bundle G, something inside the budget set, but not on the budget line. Budget line's efficient. Inside is inefficient, but attainable. We can purchase anything inside because we can afford any of these bundles. Anything outside, like bundle H, we cannot. That's outside of our ability to purchase. All right, so our budget set is just any set less than or equal to the amount of money divided by P that we get. So this minus, so this intercept right here, the price of X divided by the price of Y. So that's just the slope, right? It's the relationship in between our prices times X. If you ever remember y equals mx plus b, right, is the slope of a line. This right here, this first part, the m minus or divided by py, that sort of represents your b. Minus px divided by py over x, that's your mx part, right? Where the m was the slope of the line when we were kids doing that equation, because that's something you learn in second grade. It's not necessarily the same format here, but we're still getting at the same main point. We're trying to find this piece right here and then sort of subtract and adjust relative to how much we're purchasing of the other good times the slope. So if we start here and maybe or here, but some point along this y-intercept, we're going to eventually have to move based upon where the slope is and how much we purchase of the other good to figure out where our bundle is going to be. All right. And this, the gray part's attainable. All the white outside of it is not. The budget line is the important part. The budget line, instead of being less than or equal to, is a strict equal to, right? Because this less than or equal to means that it could be, we could choose a point anywhere in the gray. That's not what really we care about, because getting a point in the gray is not spending all of our money. And if we only have two goods in this world, we're not thinking about like the logical world where you're wanting to save money for retirement or something. We're thinking about the world where only these two goods exist and you have a bundle of money that has to be spent in between them. We want to be efficient, right? We want to operate on that budget line because that means we are maximizing the amount of money that we end up using. Okay, so m divided by py, really easy, tells us our first point where we're starting. The minus px over py, that just tells you the slope. Okay, in this, remember, so we had $2 sodas and $10 pizzas, right? That means for every one pizza that we wanted, we had to give up 5 sodas because a soda was a fifth of the price. So if I wanted to afford one more pizza, if I wanted to move over by 1 on PY, I'd have to give up 5 sodas, or reduce by 5 on PX. That's just sort of that relationship of where we slope in between, right? And how much we go down by that slope is determined by how much we purchase of that good X, or pizza, whichever one you want to look at, right? Okay, so a little bit of an example. Let's think about a situation where we want to figure out, okay, cool, we have good X and good Y. We're not even going to give them labels. You can just think of them as whatever you want to think of them as. Okay, well, in that case, let's say we have 2 points that we're debating in between. We could either purchase 4 of good Y and 2 of good X, so 2 good X, 4 good Y, or we could purchase 4 good X, 2 good Y, right? Notice that there's a slope in between them, and these are 2 similar bundles. They cost the same amount of money, but they're on this budget constraint. All right, so we need to think about the market rate of substitution. The market rate of substitution is just moving in between those 2 points. It's equivalent to the slope. So let's figure out what that market rate of substitution would be. Oh, why isn't it going? There we go. Market rate of substitution is just kind of looking at those relationships. Ah, that's a 3. Never mind. My eyes aren't working today. I've been staring at the screen for way too long, but I'm sure you have too watching these. I appreciate you keeping in with us today. We're going to rock this. All right. So the top half, remember when we were talking that the top half was related to the differences in good Y. We were looking at the change in price Y. Hold on, we'll go back. No, am I going right? Yeah, I am going right. Just losing my mind. All right, so we have like the 4 minus 3, right? So we have 4 minus 3, and we're going to divide that by 2 minus 4, because we're wanting the difference in between point A to point B. So we're going to subtract the second point. At our first point, we have 4 good Y, right? And our first point, we have 2 good X. We're at this point. Then we need to subtract what we have remaining with good Y. So we subtract 3, right? Okay. We need to subtract what our point B is for good X. So we subtract from 2 to 4. Notice this gives us a negative number, right? So we have a 1 on top and a minus 2 on the bottom. This is called the market rate of substitution, or just kind of the slopiness in between those points, right? So our budget line in this one would be equal to, right up here, this intercept point of good Y. Then we have to think about the price of good Y and the price of good X, and the changes in the price of good Y and good X are equal to the amount of Y that you would give up for them. So the change in adding these 2 X's would be by adding 2 X's would be subtracting 1 Y. And then we just move in between the 2 pieces. We calculate this market rate of substitution where we have the 4 and 2 from point A and the 3 and 4 from point B. We subtract those out to the negative 1/2, because we understand that slopes have to be negative in budget constraints. If you ever come up with a positive number, you have done something wrong. You need to restart. But we see that this is equal to negative 1/2. And then we just multiply that by X, the amount that we are creating, right? Are you confused? That's okay. We got this. I'll give you more examples and probably an additional video if anybody needs it, okay? But Y equals 5 minus 1X, or 1/2 XY. No. Y equals 5 minus 1/2 X. I don't know why I want to keep saying XY today. All right, so let's give us another example. Let's say that we have the same relationship, right? We have a certain amount of money divided by the price, and that's equal to, okay, at most we can afford this, or at most we can afford this, or some sort of combination in between them of the different budget sets. But what happens if a price ever changes? Let's say that we're looking at good X and we're like, you know what? Oh, hold on. This one at the bottom is supposed to be a PX. Please, in your notes, if you're redrawing this, please notice the fact that this good Y has MO divided by PY. This good X should have MO divided by PX. Sorry about that. All right, so MOPY to MOPX. Let's say that we are going to change the price, or we change the amount of money. So in this case, we're going to have sort of like an income effect. We're going to change the amount of money. Well, if you change the amount of money that people can afford, whoa, then we end up jumping, right? If we change the amount of money, then you can afford more of both goods. So we go from MO to M1 or MO to M1. Let me just let me try to explain this in a way that sounds a little bit easier or a little bit more descriptive, right? Because the way that the other classes teach it, and we have to kind of stay standardized in between the sections, is they teach it with this MOM, MY, PX, so on and so forth. But let's talk about this as like actual numbers. Let's think about this. What am I really saying here? So let's say that we have the $500. We have the PY of 2, we have the PX of 10, and at most we can afford 50 pizzas or we can afford 250 sodas, right? Then we have a budget constraint in between them. This budget constraint is determined by MO. Cool. What happens if the amount of money changes? Let's say that you get a big raise, right? Maybe this MO represents income. It can represent income. It can represent the amount of money that you have to spend on goods. It's just some sort of amount of money that has to do with your relationship in between Coca-Cola and pizza. So let's say that you get a raise, and that raise is that now you have M1, and at M1 you're making $600. Like, that's pretty good. That's pretty good. Congratulations. I'm happy for you. Well, what happens to your ability to be able to spend at that point? Well, you're able to spend more on both goods, right? So then if you were only going to spend, let's say MO over PX, just as a little bit easier, and MO over PY. All right, well, let's say if you only spend your money on pizza, that you end up buying 60 pizzas. Well, this is going to be equal to M1 divided by PX. Notice that the M has changed. This is equal to the new amount of money that you have available. Also, in that same way, if you now have $600 and they're $2 Coca-Colas, you can now afford 300 Coca-Colas, M1 over PY. This new relationship in between the two, notice that we can buy more of both goods. We shift it outwards by some equal amount on both sides. We call this sort of an income effect. It's the idea that, like, if we ever wanted to go here, we might instead shift here because we have more income and we might decide to purchase more, right? We're going to talk a little bit more about income effect and substitution effects when we get a bit further along, but it's just the idea of purchasing more because we can afford more of both goods, but the bundle looking kind of similar. Okay. So money can go up, money can go down. Oops. You know what? Just because I'm going to switch in between the two, we're going to just kind of keep it smaller screen just so I can easily switch. Much like we have an increase in money and we might go to M1, we might also have a decrease in money. We might go to M2. In this case, M2 is just a decrease in money. What I want you to see is that when we change M, we get equal changes, right? It either shifts out for both goods or it shifts in for both goods. But that's what happens when we change the amount of money. What happens, I don't know why it always sets like that. If we, instead of shifting the income or the amount of money that we have to spend on two goods, left or right, because we have some sort of nominal value change, what if we change the relationship of price, right? So this is another one that I don't really like the slides that the different classes have. So we're just kind of going, we're going to do our own thing real fast. Let's think about what happens when we change a price. So let's say that we have Coca-Cola and we have pizza. Again, let's have MO equal to 500. Let's have PY, and we're going to call this PY0 because it's where we're going to start, right? PY0 equal to $2, PX0 equal to $10. All right, so we got our $50 pizzas and we got our 200, or excuse me, our 50 pizzas and our 250 Coca-Colas, and this is the total amount we can purchase. But what happens when we change a price? Let's say that we realized, because this is our initial budget constraint, that maybe our pizza is just too expensive. Like maybe $10 for a pizza isn't great when Maybe I'm just not great at making pizza. Maybe my pizza tastes worse than Little Caesars. So let's get a little bit closer to Little Caesars prices. Let's say that the price of the pizza falls. Let's have a price instead, a new price. So we're going to call it X1 of $5. This pizza is now much cheaper. Well, if the price goes to $5, what happens? Well, then we get a new budget constraint. The amount of Coca-Cola that we can afford of our $500 doesn't change. So this intercept will be the same. We can still afford 250 Coca-Colas. But you want to know what else we can afford? We can now afford twice as much pizza. So instead of 50 pizzas, we may now be able to afford 100 pizzas because 500 divided by $5, that's 100 pizzas. Notice that when we have this relationship, we have a new budget constraint that instead of shifting out on both sides in a parallel fashion moving outwards like we do when there's a change in the total amount of money within a budget, we instead shift only one side. And this, we do have a new budget constraint. And if it shifts outwards, almost on a hinge or an axis like this means that there is a change in price. For us, we see that this change in price was in this price of pizza. It went from $10 to $5 and shifted outwards. So let's look at the slides again where I have about a similar situation. So in this similar situation, I say, hey, we go to some price that's now cheaper than the old price. Well, we see what happens when there's a price cheaper than the old price. Woo! It expends out one side of the budget constraint. If the price were to instead go up, it would shift inwards, one and only one side of the budget constraint, unless the price changed equally on both sides. Oh, all right, we're getting through this. Okay, well, let's look at an example. If we have sort of that budget constraint line problem that we were thinking about, in this case, let's say that M equals, remember, PXX plus PYY. That's our equation. So in this, we see this $100 is in the place of where our M was. Cool. All right. That means the total amount of money we have to spend is 100. Let's look at the next part. So we have that. Whoa, hold on. Why did my thing go weird? Okay. We need to think about the next piece, which is the price of X. So if we have M equals price of X times X plus price of Y times Y, we see that the price of X is 1. Okay, price of X equals 1 plus the price of Y times Y. This means the price of Y is 5. That means we can answer some very key questions here. For example, let's ask, what is the maximum amount of X that can be consumed? If we only consumed X, if we wanted to know what that intercept would be on the horizontal axis and we were given this equation, what would it be? Well, that means let's just forget about the Y's altogether. We're not producing any Y's. If we have 1 times X equal 100, well, our $1 X and $100, we can afford 100X, right? That's the maximum amount of X that we can consume. If we have $100 and we have a $1 good, we can at most consume 100 of them. Okay, let's think about the same for Y. Forget this X piece in there, and instead we have $100 and a $5 good product named Y. Okay, well, if we have $100 and $5 goods, and we can spend that money and buy 20 of the second good. So the maximum amount of Y that we can consume, looking at this equation where we see a 5, 100 divided by 5, that's 20. We can at most afford 20 of Y. All right, then we need to think about what the market trade rate of these goods are. Essentially, what is the slope going to be, right? When we, at the end of the day, want to think about the relationship in between them. Well, we know that X is $1 and Y is $5. So what rate would they be trading? Well, if I wanted to increase one of good Y, that's a $5 good. What am I having to give up to buy a $5 good? Well, probably 5 of this $1 good, right? So the market rate would be for each additional Y that we add, we have to give up 5X. Well, when we start to think about that, we know that that means, or well, here, we can just draw it. Why not? Why not? It's always good to draw things. Okay, well, that means, here, we'll just keep scrolling down. Scrolling. If it feels like it, here, we'll use this blank space over here. So Let's look in this box. All right, so this means if we have good y and we have good x and m equals 100, we know that we can afford 100x, which is because x is $1, or we can afford 20y because y is $5. If we needed to know the slope in between them, first off, we know that that slope is going to be negative. See that it decreases as we add more of the other thing. Slope has to be negative. Okay, well, if we wanted to add, well, let's say 1y. Let's say we wanted to add 1y. Well, how much of good x are we going to have to give up? Well, to add 1 of good y, to go from maybe 18 to 19 of good y, we would have to decrease by a larger amount of x to equal that same amount, because y is a $5 good, while x is a $1 good. So to increase 1y, we're going to have to give up 5x. So all right, -1/5 would be our slope, right? It's just a negative slope to it. We call this the market trade, or the rate of market trade. Just essentially, how much would you have to give up of one to get the other one? I have the answers in the next one in case you're interested. But the market rate of substitution in this one is just the negative of whatever the relationship between the price of x and the price of y is. So instead of drawing it out, you don't necessarily have to. You can plug in those prices that we already have. So notice with that one equation, there are already so many things that we can answer, or that we know about this market and what we can afford in that budget constraint piece. But we also need to think about consumer preferences among them, because let's think about it. And well, this is also just kind of preferencing what we're about to get into, but can you maybe, what if we add a page? Can I have a new page? Ah, wonderful. Sure. So let's say that we have, because we have two important pieces of information that I've told you about so far. We have sort of this curve of people's preferences, right? We called this an difference curve. I obviously can't spell, but that's okay, because I decided to do math for a living, not spelling. And then we have our budget constraint. So y, x. We have some relationship in between what we can afford. So m over the price of y, and then m over the price of x. All right, how do we add the two of these together? These are two important pieces of information that tells us the consumer preferences and the affordability. And with affordability, almost the efficiency, right? What would be efficient to purchase? Because we want to purchase on that line where we maximize the use of our funds. Okay, well, when we need to think about adding these two pieces together, we have to think about something called consumer equilibrium. Consumer equilibrium is the bundle of consumption that is affordable, right? It has to either be within or on the line that gives the greatest satisfaction to the consumers. So each of our bundles of goods, we're only assuming is having two goods right now. Either it has pizza or Coca-Cola, good X or good Y, and some combination of the two. I'm not considering vending machines. I'm not considering good Z. I'm not considering tomatoes. I'm not considering good L. Like only good X, good Y. Coca-Cola, pizza. Those are the only things that we are considering in this model at this time. So if consumers have to choose some bundle of goods, whether it be 100 pizzas and 25 Coca-Colas, or 50 Coca-Colas and 10 pizzas, or some combination of those different things, consumption bundles are where a consumer chooses the marginal rate of substitution, this kind of curvature that I saw to trade in between X and Y equals the ability to purchase it, the market rate of substitution. So, well, we're going to get into it. But first, let's kind of look at putting those two together. Actually, let's draw this. Let's draw this first because I just don't like the slides. All right, so we have this like level of indifference that people kind of feel indifferent in between, right? So each one of those curves, each one of the curves up here represents that this consumer would be happy, the same level of happiness anywhere on this curve. If you gave them this amount of good X and Y, they would be just as happy as if they had this amount of good X and Y. So let's think about it as, let's say, our Coca-Cola and our pizza, and our nice little budget constraint in between them. So we got our 50 pizzas and our 250 Coca-Colas, and we just ignore the fact that our scales aren't mattering right now. Okay, so we have this budget constraint. Now we need to add in that indifference curve, the bundles of goods that consumers are indifferent in between. Well, we might have one way up here. Where I would be just as happy at this point as this point, but notice I can't afford that set of goods. I might have one way down here. Like these would make me okay happy. Indifference curves. But notice that like I'd be just as happy spending almost no money as maybe spending that $250. Stop it. If I spent the 250 here or the why? Okay, so I promise I will buy a new tablet before we come back to class because I don't know what's going on today. All right, so I'd be just as happy spending that $250 on this good or this good, or maybe not spending nearly as much money at all or buying some bundle in here. Well, this is attainable, right? Like this inside part, this is attainable, but it's not efficient. It's not using as much of my money as possible. Maybe instead I might have another indifference curve right here that just barely touches it, where we only touch by 1 point. Okay, well, let's talk about what the differences in between these are. First off, you're probably like, what is all these indifference curves? Why are they like that? Why do they look like that? Well, let's assume that this first line maybe gets you 1 happiness. We'll give this little heart, 1 level of happiness. Maybe the second one gives you the second level of happiness. Anything on this point will give you 2 levels of happiness. Maybe this next line gives you 3 levels of happiness, right? We want to be at the most amount of utility possible, or the most amount of happiness for our goods. So though we can afford and attain this first one, we're just like, okay, well, that's cool. That's pretty neat. But I only get 1 happiness point. I only get 1 utility, 1 indifference. Okay, let's think about the next indifference curve, maybe right here, where notice that I can still afford this. It's efficient because it's on the maximum amount that I can afford, but I get 2 happiness for it. I maximize my utility. I'm even happier for having this good. So utility curves are a series of these curves that they move in parallel up and up and up. And we want the indifference curve where we are the most amount of happy with the, or most amount of happy that we can be within the 2 goods while using all the money we possibly can, right? While we're efficiently maximizing our budget. So when we're efficiently on this line, what's the furthest out one of these curves that we can touch? In this one, it's that 2 utility point one, right? While instead of this 1 utility point one where we may not be happy, or this 3rd utility point one where we might be even happier, but we just cannot afford it. Okay, so this kind of shows you a similar thing, right? It's way prettier than my drawing because my drawing is terrible. But let's say that we have good X and we have good Y. Well, here we have 3 indifference curves. Notice that it's indifference curve 1, 2, and 3. Okay, well, indifference curve 1, I'm somewhat happy. Like it's okay, that's fine. And I can afford most of these bundles of the indifference. So if I'm right here, I can spend not much of my budget whatsoever and still be just as happy as I would be at point A. Point A, I would be level 1 utility indifference curve happiness for the amount of money that I want to spend, or what would be efficient for me to spend. But like that's not as happy as I could be. Then I could go to indifference curve 2, right? It's just noticing shifting outwards. I get a little bit more utility. I get a little bit more satisfaction or a little bit more happiness for this second indifference curve. Again, I can afford a variety of different bundles. Here I see that I can afford bundle B, or I could afford something on the inside that's not efficient. I'm not using all my money, or I could afford something right here. We continue to push out to the next level of indifference, where we get even more utility. We call this one 3. Indifference curve 3. Indifference curve 3, I am indifferent in between any of these bundles, but notice that I get more utility. It is further away from 0 than as I would for indifference curve 1 or 2. Well, as we're going down this curvature, notice that we only touch the budget constraint once. We only have 1 little point that touches the budget constraint. Well, curves or indifference curves that only touch your budget constraint in one place mean that we are maximizing the amount of satisfaction and utility that we can get from a bundle of goods while using the amount of money that we have available. For this budget line right here, getting to point C for indifference curve 3 is the absolute most amount of happiness that we can get, or the most amount of utility or satisfaction that we can get is purchasing that bundle of goods. That is exactly where we want to be. We are happier at C than we are at B. We are happier at B than we are at A, and we are way happier at C than we are at A, keeping this transitivity property. All right, we call this point where we have an indifference curve that comes in showing consumer preferences only meets the budget constraint, the amount that we can actually afford. If it only touches it once, we have met consumer equilibrium. It is the most amount of utility that we can get for this consumer with this budget, with this bundle of goods. Right? Shake it out, think through that. Now, what if we had point D? You say, okay, well, this is indifference curve 3, our third level of utility. That's good. How about we have an even higher level of utility? Let's go to D. Maybe that's like indifference curve 12 or something. Like, let's go there. We cannot attain that. It is beyond our budget constraint. We cannot afford D. What we're wanting is whatever the maximum amount of happiness or satisfaction we can get for the amount that we can afford currently, right? So there might be price changes. Notice that the price changes move that budget line. Well, if we move the budget line, that would affect which one of these we're hitting. If I all of a sudden had more income and we're up here, I might be able to afford D. If we all of a sudden drop the price of X, well, that's also going to change where these lines are. And we have to think about these price changes and what they mean for consumer behavior. Can we get to further levels of utility when we change prices? Turns out, we can typically get to a better bundle when we purchase or when prices go down or when income goes up than what we would have had otherwise. So price and income changes impact the consumer's budget set. That line of like the maximum amount we can afford, that gets affected by prices and income, right? Or prices and the total amount of money that we have to spend on a good or service. This implies that price and income changes will lead to consumer equilibrium changes. So, okay, let's just keep going through this. Let's talk through this and then we'll continue with drawing and graphing things. So you need to think about price increases. Price increases reduce the consumer's budget set. Price increases shift that point inwards, remember, and then your budget line kind of contracts closer to zero. Price reductions can expand the consumer's budget set. Notice that it hinged outwards and you were able to afford more things when prices go down. The new consumer equilibrium, the new point where we get to the maximum amount of satisfaction that we can for a good or service, depends upon the consumer preferences. And these consumer preferences will really matter depending on if something is a substitute or if something is a complement. So if they're substitutes for one another, if good X or Y are substitutes of one another, then you just buy what's cheapest, right? Like you don't really care if the price of good Y is going up. If the more it goes up, you just buy good X because they're substitutes for one another. It also matters if they're complements. If they're complements, then that means, oh, okay, well, I got to buy them together, right? So if the price changes for one, I will have to change the amount I want of both because I want an equal number of both. All right, what does this mean? Let's look at it. Let's say that this is our budget constraint, and this is the level of indifference curve in which we maximize our utility relative to this budget constraint. So this is the indifference curve that touches just once that budget constraint. If you're not understanding me on that, let me know. We can work on it. We can do that. Okay, but let's say that this is point A. At point A, we have some amount of good X and some amount of good Y. Yeah, let's call it XO and YO. That's the bundle we're at. We found out that out of all the amount of Y's that we can have, with all the amount of X's that we can have, we get the most happiness when we purchase YO and YX. Okay, so point A is our initial consumer equilibrium. Let's just keep that in mind. Let's keep that in mind. But let's say that there's a price decrease, right? This is what I showed you earlier when the price of pizza went from $10 to $5. And we're going to see that outside hinge. right? We're going to move outwards. Well, if we can now afford more pizza than we could before, or more of this good X than we can before because of a price change, are we going to stay at point A? Well, no, right? Notice that we have this new budget constraint. With the new budget constraint, A is now more than it's definitely attainable, but it's no longer efficient. It's no longer on that budget constraint line. Like, you can purchase this all day, but like, it's not maximizing your happiness. It's not maximizing your consumer satisfaction. We want to get back to a point that would only touch that new budget constraint once. So then we would be like, oh, okay, well, maybe I'll just shift straight out. Well, if you shift straight out, we go in a 45-degree line outwards, we get here, we notice that that's not where our happiness point is either. We might have shifted maybe a little bit more to this now cheaper good. We sometimes call that like a substitution effect, when we start substituting from one good to another. So if the price of good X decreases, we'll see that we'll want to move from A to B in between indifference curve 1 and indifference curve 2. Indifference curve 2 means we're now more happy, and the reason we're able to be or have more satisfaction or have more utility is because we now have cheaper prices. So now we have a new consumer equilibrium. We've gone from A to B, new consumer equilibrium, super cool, because since the amount, but notice what happened here. Notice what happened here. At good A, we had Y0, X0. At good B, we have Y1, X1. We have massively increased the number of X. Going from XO to X1, that's a lot of new X, right? But notice, we didn't only add more X. We didn't only buy more pizza. We still have rules. If we want to buy more and more of one good, we're still going to have to give up some of the other good if we're efficient and on a budget constraint. So notice in this, we massively increased on our pizza side, but we reduced some on the Coca-Cola side. We went from Y0 to Y1. We had a reduction that happened there. Well, since Y1 is less than YX, we conclude, since we reduce the amount of Y1 that we have, we conclude that X and Y are substitutes. Here's why. Here's why. Listen to me. We got this, right? There's a price decrease in pizza, and you bought a lot more pizza, but you gave up some soda, right? You went to the checkout and you actually bought less soda than normal because you bought way more pizza than normal. Well, that means that you would have sold Coca-Cola and pizza as substitutes. You were willing to give up some extra Coca-Cola to be able to get more of this cheaper pizza. You saw them as kind of just as good for like satisfying your needs. You're like, you know what? I can substitute away from this. I don't need as much Coca-Cola. I can get more pizza. I find them to be kind of interchangeable in my preferences. That's something that we see here if we end up reducing the amount we have of one. And that is freaking cool. This relationship right here shows you how your customers think. This right here shows you how people make decisions in between goods and what goods they like together and which ones they don't. And this is just a simple graph that shows you a much deeper perspective into consumer behavior theory. I love teaching this to my undergrads because I always see their little eyes just shine as they get it, and it's amazing. And we talk, it's wonderful. So that's kind of what happens when we have a price, right? We see this price change. In this one, we see that they're substitutes. If Y0 did not reduce, or instead our Y1 ended up increasing. So maybe we go from point A to maybe right here where my cursor is. Maybe this was where our new indifference curve was. Well, if our new indifference curve was here and we increased both XO to X1 and we increased YO to Y1, we did both of those and they both increased, not by an extreme amount, but they both increased, then they would instead be complements. They were things that we were trying to consume together. All right, so income can also affect things. Income increases is moving the entire budget constraint in a parallel fashion. It's not hinging out one side, it's moving the entire line up and down. Income increases can, what? I think I have that backwards in here. Anyways, income increases mean that I can now purchase more things, and that's great. The new consumer equilibrium resulting from an income change depends on consumer preferences. Oh yeah, I think I do have this wrong in the slides. Okay, I'll go in and rewrite it. But income increases end up expanding the consumer budget set. When you have more income, you can buy more things. Income decreases reduce the consumer budget set. When you have less income, you can buy less things. All right. The new consumer equilibrium results from an income change depending on consumer preferences. Whew. We need to find out sometimes if one good is normal or inferior, right? Remember those examples I gave you earlier when we were thinking about the elasticity and we started talking about normal versus inferior goods? Normal goods are ones that you buy more of when things are good and you buy less of when things are bad. Inferior goods are things that you buy less of when things are good and you buy more of when things are bad. Think about like emergency rations or ramen noodles or the like cheap off-brand mac and cheese that like is definitely not the same. Those are the things that happen with inferior goods, and normal goods are the opposite, right? They're the things that I want to buy when things are good. So let's think about income changes in consumption and trying to figure out if, like, for example, good X or good Y is a normal or inferior good. So in this one, we have two goods. We have good X, good Y. We have our pizza and our Coca-Cola, whatever you want to call it. And we have our initial consumer equilibrium. Again, this is right where our budget constraint is maximized and we are only touching our indifference curve once. And that's because this is the furthest out indifference curve that we are able to touch with this budget constraint, and we are maximizing the consumer welfare and happiness and satisfaction relative to the budget set for these two goods. All right, so point A is the initial consumer equilibrium. Let's say that we increase our income. Our M has grown. We've gone from the $500 for pizza and Coca-Cola to the $600 for pizza and Coca-Cola. We already kind of talked through this. Now we just get to see what it looks like when we have this swoopy little indifference curve. All right, so let's say that we increase the budget constraint. Notice that that's a parallel shift outwards. It's not hinging on one side or the other. It's an entire shift at this line. So we go from MO to M1. That's the idea of going from like the $500 to the $600 in our previous example. Notice that we have this straight outward movement of A to B. This is because it tends to be an income shift, right? We buy a little bit more of both things because this is already this kind of distribution of goods that we liked. So if in difference curve 2, we see that we have this line come in, right? Woo! And that's our new level of utility and happiness. Whoa, is that it? No, that can't be it. Okay, guess that is it. All right, so with our new consumer equilibrium, notice just with our income changes, we shifted all outwards. Okay, that's a lot of things. Actually, I think I know why I cut off the slides here. It's because I put some of it onto next week because I already felt like this was too much because it's a lot of concepts, right? We went over a lot of things today. We went over elasticity, 4 different measures of elasticity. We went over the idea of indifference curves and what consumers are indifferent in between. We started thinking about the rules of preferences and the rules that we have to have together during preferences. We started thinking about the slope of lines, what happens when we adjust prices or income, and what that looks like for our budget constraint and our indifference curves when we're trying to figure out the consumer equilibrium. Wow. Okay. So with all of that, your case study tends to go a little bit more into real life applications. So it's going to be using a lot of these theoretical pieces that we're talking about and putting it more into the perspective of like what actual business making decisions are, similar with your assignment and quiz. Your assignment and quiz tend to be very similar to one another where the questions are close, right? Good luck. If you need anything from me, let me know. I am always happy to work with y'all any step of the way, and have a great week. I look forward to seeing you all next week again in the videos. Bye.